A unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. And there is nowhere more mysterious than Death Valley, the hottest and driest desert in the United States. This is a place where even 700-pound rocks appear to move by themselves. It's the lowest point in the U.S., and right here, the Earth's crust is thinner than almost anywhere else on the planet. Death Valley is a dynamic laboratory for investigators who uniquely read rocks like X-rays to reveal the inner workings of the Earth and its history, adding to the continuing story of how the Earth was made. Death Valley is the largest national park in the lower 48 states, more than 3 times the size of Rhode Island. Straddling the border of California and Nevada and surrounded by towering mountain peaks. 140 miles long and up to 15 miles wide, with temperatures reaching a scorching 134 degrees Fahrenheit. This is one of the most inhospitable places on Earth. But for geologists, Death Valley has a unique attraction. Here, they can witness the interplay of the Earth's most titanic geological forces.
When you look at Death Valley, really you're looking at a battle between processes that are occurring on the Earth's surface. And we can see the record of those forces of nature locked into the rocks. Death Valley has an archive that is almost unrivaled worldwide.
To uncover Death Valley's earliest history, Trove is hunting for its oldest rocks. He is searching in one of its most remote spots, in the extreme south of the valley, in the isolated Alexander Hills.
This is one of the oldest rocks in Death Valley. It's 1.2 billion years old. And given the color of this rock and the fact that it's quite soft, it can powder when I scratch it, these are all clues that tell me that this is a limestone.
The limestone is a major clue to revealing the way this arid desert used to look.
If we think about the type of environments that limestones can be deposited in, the first that comes to mind is an underwater in a marine setting.
There is only one way to form limestone. It is made from the tiny bones and shells of sea creatures. They die and sink to the sea floor, where the weight of further layers on top of them crushes them slowly into solid rock. And Trove has discovered other startling evidence that Death Valley had a watery past.
Fossils are a major clue. They are vital in the type of evidence that a geologist will use. And these are some very nice examples of the type of fossils that you can find in these ancient rocks. And you can see here these curving surfaces outlining what look to be large cabbages that are sliced in half. These were algae, known as a stromatolite.
Ironically, these marine fossils have survived in the Death Valley desert only because there is so little water that might otherwise have washed them away. But they would have originally looked like this when they flourished in the Death Valley waters as the limestone formed more than 1 billion years ago.
These tell us that the environment, when this rock formed, would have been a shallow sea. If I'd been here when these rocks were first being formed, I'd be sitting in my swimming trunks about waist deep in water, very much like the Bahamas today.
The stromatolites are some of the earliest signs of life on our planet. To discover what happened over the next 1 billion years, Prave studies evidence in the surrounding hills.
The different bands of colors and the rock layers and the hills represent ancient seas that covered the Death Valley area. The seas would deposit a layer of limestone, move back across the land, another layer of limestone would be deposited. And so we have a history of the seas moving across the Death Valley region from the time of the stromatolites to these rock layers now, more than 1 billion years later.
Geologists wanted to figure out what dramatic geological upheaval could have turned Death Valley from a shallow sea to the baking hot desert of today. And Prave has found clues in a rock that is entirely different from the marine limestones he has studied up until now.
This is a nice example of a rock type called a granite. And it forms those veins that are in the hillside behind me. You can think of these like the fingers of my hand. They're fed upward from a much more larger, massive area of granite sitting underneath.
The granite tells scientists the reasons why Death Valley's ancient seas vanished. Today, it is solid rock, but it was once hot, molten magma from deep underground. Only one force of nature has the awesome power and 2,000 degree Fahrenheit heat to melt rock into magma and fire it to the surface. Volcanoes. The seas here didn't just drain away. They were pushed back by these mountains of fire. It was only in the 1960s, with the realization that Earth's continents were drifting around the planet, that scientists figured out why the volcanoes erupted under Death Valley. The theory of plate tectonics revealed that around 100 million years ago, an ancient oceanic plate began sinking under North America, pushing up the land. Heat from the collision powered a coastal chain of volcanoes, erupting on the land and finally driving away the seas, submerging Death Valley.
This landscape would have been very explosive, a hostile type of setting, and that then set the stage for what was to become Death Valley.
Still surviving in the valley to this day is the ghost town evidence of another substance, far rarer than granite, that the volcanoes brought to the surface. Gold. Although gold occurs naturally in more than 30 different U.S. states, the gold in Death Valley was concentrated in veins in the rock as magma solidified near the surface. It made it worth mining, and millions of years after its formation, it sparked the Death Valley gold rush.
It's a wonderful example of a gold mine shaft. It's the Eureka mine, high up in the Panamint Mountains, associated with trying to find gold in the granites that were intruded into these rocks 100 to 200 million years ago. The gold would have been in veins, these fingers would have been injected up into these rocks, and the gold would have been concentrated in these veins.
The gold rush here lasted just a few years. Miners often had to remove a ton of rock to recover only 1/10 of an ounce of gold, enough to produce just a single wedding ring. Today, all that remains are empty tunnels and ghost towns.
It's interesting to consider that the frenzy of activity, mining gold, was actually a direct result of the kind of volcanic activity 100 to 200 million years ago.
Geologists investigating the battle that raged in Death Valley between fiery volcanoes and ancient seas have found important evidence. Stromatolite fossils are proof that Death Valley was once submerged by the waters of a shallow sea. Veins of granite could only have formed in the fiery heat of the volcanoes that burst to the surface around 100 million years ago and drove that sea away. The volcanoes built up the land that was to become Death Valley into peaks as high as the Cascades mountain range. But deep beneath the Earth's surface, awesome geological forces were about to destroy those peaks, stretch the land apart, and transform the mountains of Death Valley into the lowest point in the U.S. For a billion years, Death Valley remained a flat plain under the sea. Around 100 million years ago, erupting volcanoes formed high mountain ranges. But then, the real geological mystery began. The land here must have undergone an extraordinary transformation. Because today, in Death Valley, those high mountain ranges have vanished. Incredibly, the one-time mountains have sunk below sea level to become the lowest point in North America. Yet all around the valley, snow-capped peaks still soar up to 11,000 feet into the air. The investigation digs deep under the landscape to discover what vast geological forces could have caused that huge difference in height between two places, just 20 miles away from each other.
There are a lot of mysterious aspects about Death Valley. It's a unique landscape because the valley floor itself is very deep. It's below sea level, and the mountains rise up very steeply on either side.
Clues to the power of these underground forces lie all over the valley, if you know where to look. Many of the rock layers were originally deposited on the ancient flat seabed. They can still be seen as horizontal layers. But other nearby layers aren't horizontal at all. They tilt downwards into the ground. Miller finds a further clue of Earth's power in the unusual shape of this cinder cone, a mound of ash and debris lying on Death Valley's floor.
It looks like it's two cinder cones, but in fact it's really just one that's been pulled apart along a big fault zone. This has moved some 700 feet in some 700,000 years, so that's about a foot per 1,000 years, which sounds like it's really, really slow, but if you look at it over a great length of geologic time, you get quite a lot of slip. And give it even longer time, it'll be offset even more.
Miller's next challenge is explaining what is making the fault line move. For that, she studies other ancient rock formations whose jagged outline has given them the name turtlebacks.
The turtlebacks are crucial to understanding Death Valley's early origins. They have so much of the record here if you're willing to spend time to try to unravel it.
The real clue lies in the rock's distinctive texture.
If you just take a look at this rock closely, you can see that it's very kind of strung out, very stringy. It tends to be pretty fine-grained.
This texture tells Miller where these rocks came from.
We see evidence that these rocks were deformed, just like if you take a piece of plastic and were to heat it up, you could bend it. It's the same thing with rock. And so these rocks formed at high temperatures and pressures within the Earth's crust at depths of about 10 miles or so. And they have since been brought to the Earth's surface.
Miller concluded that some overwhelming underground force must have raised the turtleback rocks to the surface and stretched them out like warm toffee as Death Valley formed. The final explanation of what happened here, once again, came back to the way continents drift around the globe. As the collision of the plates that had forced ancient volcanoes to the surface slowed down and ceased, The high mountains that once dominated the land were slowly pulled apart and tilted downwards. Gradually, as the underlying crust grew thinner and thinner, a deep basin formed between the mountain ranges. Death Valley is the most extreme example of what such stretching forces can do. By measuring seismic waves, scientists discovered that here, the continental crust is just 16 miles thick. This might sound like a lot, but it is far thinner than almost anywhere else on the planet. Around the globe, the Earth's continental crust averages 25 miles thick. It's strongest beneath the Himalayas, at 43 miles, thick enough to support the weight of massive mountains, such as Everest. The Turtleback rocks also offer Miller evidence as to when Death Valley's stretching started. Dating these rocks reveals that the deformation started here around 13 million years ago, although Death Valley did not take on its final shape immediately.
Death Valley's really young when you look at the whole geologic timescale. Modern Death Valley is probably 3 or 4 million years old at the most. The stretching started before that, but Death Valley itself is a very recent feature.
Scientists know that the process is far from finished. They've found irrefutable evidence in the alien Death Valley landscape known as Badwater Basin.
I'm standing here at Badwater, which is the lowest point in the Western Hemisphere. It's 282 feet below sea level. We're actually standing below sea level about the depth of a football field. This floor has been sinking. It's about 1/10 of an inch per year, which is about half of the speed at which your fingernail grows.
Continual stretching of the Earth's crust has turned Badwater into one of the lowest spots on any continent on the planet. Yet, its true depth is even lower still.
The surface that we see here is the present-day surface. But what one has to realize is that beneath our feet, we can go down through sediment that represents ancient periods of time when Death Valley was a surface that goes down 3 miles.
You would need to drill down through the sediment to a depth equivalent to 11 Empire State Buildings end to end before you hit the crustal bedrock. The total volume of material in this basin would bury New York to the depth of nearly a mile. The valley floor is constantly being covered with sediment cascading from the surrounding mountains. But it can never fill up completely.
The sediment is coming in at a rate that is less than the rate of sinking of Death Valley itself, so that we're always maintaining a surface here on the valley that is sitting below sea level and is continuing to sink through time.
This constant movement shows Earth's geological forces at their most dynamic and makes Death Valley unique.
The allure is that nowhere on Earth do we see continental crust being pulled apart at this rate or this magnitude.
The investigation into Death Valley's creation has established how it sank to become the lowest point in North America. The Turtleback rocks were deformed by the powerful tectonic forces pulling the mountains apart to form a wide valley floor. The still sinking landscape of Badwater, currently 282 feet below sea level, is proof that the crust here is still being stretched today. But the sinking of Death Valley is just one part of the story. Geologists still need to investigate how one of the hottest places on Earth was shaped by the power of moving ice. $1.2 billion years ago, Death Valley was submerged by ancient seas. Around 1 billion years later, volcanic mountains drove the seas away. 13 million years ago, the continental crust started stretching apart here. And by 3 million years ago, Death Valley was one of the lowest points on Earth. The clue that showed investigators what happened next was the discovery in the valley of a little-known but highly valued white crystalline rock.
When one thinks of prospectors in the Death Valley region, one often thinks of them hunting for gold and for silver. But there was one mineral that was much less glamorous, much less sexy and exciting, and that was borax. But it was actually known as the white gold of the desert.
In 1880, borax was a rare but in-demand mineral used in antiseptics and detergents. One impoverished couple desperately trying to make a living in Death Valley was Aaron and Rosie Winters. They heard from a passing prospector that they could make good money from borax if they could find it. They learned from their fellow prospector the then secret method of testing rock for borax. Anxious to keep potential profits for themselves, the couple waited until the dead of night to perform the test in Death Valley.
You burn the mineral to see if the powder that we have in front of us here contains any borax. Now, what the Winters did is to add sulfuric acid to borax-bearing mineral. We'll add some alcohol. The Winters probably used cheap whiskey back in 1880. And the flame should burn, hopefully a green color, if borax is there. And as we can see, the flame is green in color. And in 1880, the Winters knew that they would become wealthy because they had borax.
From these humble beginnings, a whole industry grew in Death Valley. It made the Winters' fortune and also gave scientists a priceless clue in their quest to understand the geological history of Death Valley. Because borax deposits like these can only be found in the beds of ancient freshwater lakes. The seawater that once covered this valley had long gone, 1 billion or more years earlier. But the presence of borax proves that fresh water must have flooded into the area when Ice Age glaciers started to melt from the surrounding mountains around 200,000 years ago. As the glaciers melted, rivers flowed towards the lowest point, Death Valley. Gradually, a vast lake spread out across the flooded valley floor. The valley's catchment area was huge. Its rivers drained more than 9,000 square miles, an area bigger than New Hampshire. The water pouring in from the surrounding mountains leached minerals such as borax from the rocks and deposited them on the lake bed.
In a lot of the lake beds, this mineral, borax, would appear as a kind of a white fuzzy mineral. It was actually called cotton ball.
The borax proved that a lake existed here. Geologists called it Lake Manly, after one of the pioneers, William L. Manly, who had named Death Valley in 1849. But they had no evidence to tell them its depth and its size. A solution to this puzzle is revealed in this small hill with a road cut straight through it, near the valley's edge at a spot called Beatty Junction.
It's very fortunate to have a road cut right through this gravel deposit. So in the exposure, we can see very well-rounded pebbles. We can also see some crude layering in the gravels, and they're stacked in against each other, and we call that shingling.
The shape and the smoothness of the stones tells Caskey exactly how these pebbles got here.
The way they're stacked tells us that the direction of water flow that laid these pebbles down like this was from the right to the left, so we know that this had to be wave action. That's strong evidence that this is a beach environment.
By looking at the height of this pebble beach above the valley floor, Caskey calculates the dimensions of the lake.
From this beach gravel bar that we're standing on, the waves would have been crashing at our feet. And as we look south, it's hard to imagine a lake sitting out there across that vast salt pan, but Lake Manly would have covered about 600 square miles, and it would have been about 450 feet deep. It's odd mapping shorelines on a really hot day in Death Valley. You kind of long for the ancient days of yore when there were big lakes out here. You imagine this was a beautiful place, full of lush vegetation. Yeah, it was quite a different place than it is today.
For Caskey, the next step is discovering why Death Valley no longer has a lake. And there is evidence about that in one of its most unusual landscapes. This twisted, jagged field of white peaks that's called the Devil's Golf Course. Even the sounds here are mysterious. In the silence of the desert, there is a faint popping noise as the relentless sun sucks every drop of moisture out of the parched surface.
The salt that we see here is the remains of an ancient lake. It's called Devil's Golf Course because it's probably the least likely surface that you would ever want to play golf on.
The surface is made up of rough salt crystals, popping when they expand and contract in the searing heat. But this salt did not come from the sea. Just like the borax, the salt was leached from the rocks when fresh water started flowing into Death Valley 200,000 years ago. The salt was originally dissolved in the freshwater Lake Manly, and Caskey has a simple experiment to show exactly how it ended up on the floor of Death Valley.
I'll pour the water and salt solution into this pan, and as the water evaporates, we should see salt forming, and that's exactly how this salt crust forms. So, it's hot enough out here today, it should evaporate pretty quickly. In a fairly short amount of time. Some beautiful salt crystals formed along the edges, but that's essentially how a salt pan forms. When the rainwater comes in, the salt goes into solution, basically just like the water that we have in this water bottle. And from the moment the water starts evaporating, salt crystals start forming.
Today, Death Valley's salt pans cover more than 200 square miles, an area 3 times the size of Washington, D.C. They are the remnants of the ancient lake that finally disappeared 2,000 years ago when Earth's climate began to warm up. From then onwards, Death Valley's temperatures just kept on rising.
Well, Death Valley is definitely one of the hottest spots in the world. The record high was 134 degrees Fahrenheit, recorded back in July 10th, 1913. And just to give you perspective on that, the caretaker of the Furnace Creek Ranch, who actually was the one doing the recordings back then, he describes that day as being so hot, he saw the swallows falling dead in flight.
Geologists today understand how Death Valley's unusual geology is responsible for the punishing climate that killed off its lake. It stays so dry because there are 3 distinct mountain ranges between Death Valley and the moisture carried off of the Pacific Ocean, over 200 miles away.
Where we have the Sierra Nevada to the west of us. The storms come in from the west, laden with moisture. As they rise up, they lose most of that moisture on the west side, and each set of mountains wicks a little more moisture out of the clouds. And here, with our 3 sets of mountains in between us and the ocean, by the time that moisture gets to Death Valley, there's either all gone or we just get a few drops of rain.
Almost all storms from the coast are stopped by the 3 mountain ranges, each one in turn having an effect the scientists call a rain shadow.
So we are in the rain shadow of a rain shadow of a rain shadow, and average less than 2 inches a year.
And there is another way that geology influences the desert climate. Air heated under the cloudless sky is trapped by the surrounding mountains. In summer, Death Valley becomes a deadly dangerous furnace. The local weather station provides a graphic demonstration of how quickly that heat could have destroyed Death Valley's lake. Every day, Callaghan checks the rate of evaporation.
The summer months, it may take 5 of these containers here, so I'm going to fill them up and dump them into the pond until it brings the water level up to the needle. Now, our average rainfall is barely 2 inches a year, but the evaporation pond records up to 150 inches of evaporation.
That huge discrepancy between the amount of rainfall and the speed of evaporation means that a lake 12 feet deep and 30 miles long would evaporate in just a single year. Lake Manly was bigger than that, but over time, it never stood a chance. The scientists' studies of Death Valley have solved the mysteries of its freshwater past. Borax, discovered here in the 1880s, proves that Death Valley was once filled with a freshwater lake. Pebbles unearthed on an ancient shoreline show the lake once covered 600 square miles, an area 3 times the size of Chicago. When the last freshwater pools dried up here 2,000 years ago, Death Valley started its reign as the driest place in the U.S., which makes it ironic that the investigation's next phase, examining the valley's most recent geological upheavals, involves scientists studying the awesome power of fast-flowing water. Around 100 million years ago, Death Valley's ancient seas gave way to exploding volcanoes, whose peaks were then wrenched apart to create the lowest spot in America. From around 200,000 years ago, the valley filled with a freshwater lake, but the rain shadow of surrounding mountains dried up the water. For the past 2,000 years, Death Valley has been hotter and drier than anywhere else in North America, which makes it all the more mysterious to find Mosaic Canyon, a deep chasm seemingly cut by water in this parched and arid land. Especially when there is evidence of massive boulders having been pushed around like pebbles.
Just look at the size of that boulder and look at how high above my feet it is. It's about 3 feet in diameter, and I can't even estimate what the weight of that thing is.
She may be in a desert, but Messina knows there is only one force that could have lifted the boulder up so high.
Water brought it here and left it here. The force of the water that came through here had to have been pretty severe in order to get that boulder up there, plastered against the wall. This boulder gives us evidence about the force of the water that comes down these canyons during flash floods.
A flash flood is one of nature's most lethal weapons.
If there were a flash flood coming down this canyon, I wouldn't have enough time to run out of its path because the water flows down at an incredible velocity. Flash floods are among the most violent processes on the Earth. They can carry material the size of an SUV without any problem at all.
In one of the driest places in the world, the floodwater comes from a surprising source: rain. On average, Death Valley receives just 2 inches of rain a year. This is less than half the rain that falls on New York in a single month. But violent summer storms mean it can all fall in just a single day. The floods transform the desert landscape in a number of ways. One is known as the desert bloom, where seeds and plants that may have lain dormant for up to 10 years burst into flower after a sudden rainfall. This phenomenon might be beautiful, but there is another deadlier side to these floods, with a human cost.
In 2004, there was a flash flood that came down Furnace Creek. It was just this muddy slurry that was dense enough to pick up a vehicle and carry it downhill, and several people died in it. The 2004 flash flood is small in comparison to some of the events that we see preserved here in the rocks.
Flash floods happen all over the world, but there's evidence here of their particular and rare geological effect in Death Valley.
This marble is very highly polished. It's not scratched, it's not gouged. It's been polished by very fine-grained material. It comes down as part of a flash flood. So it's really smooth and it's fluted. It's really unique.
To uncover how these unusual polished walls were formed, Messina takes a closer look at what geologists term the Badlands.
I think it's called bad because nothing will grow on it. There's just this very loose material out here, and it erodes so readily that plants can't even take root. So this is bad land.
The rock that makes up the Badlands is the dried-up remains of the 2,000-year-old lake bed that once submerged Death Valley.
This is nothing more than desiccated mud. It's called mudstone because it's slightly lithified, meaning it's turned into rock.
The mudstone's minerals are arranged in tightly packed, flat sheets.
The rain can't penetrate the mudstone, and therefore the rain picks up a lot of particles and carries them downhill.
These particles are the key to the canyon's smooth, polished walls.
It flows through here so laden with sediment that it causes a lot of polishing and incision. So every time a flash flood comes through, this canyon gets deeper, the walls get higher, and the rock gets more polished.
The sediment-laden floods can carve into Death Valley's rocks with tremendous speed and force. These canyons have been gouged out where the rocks here have been fractured and weakened by the continuous stretching the valley is undergoing.
This is upfront, in-your-face geology happening right here. Death Valley is dynamic. This is a place where things are happening in a human lifespan.
In this arid desert, the investigation has identified water as the latest factor in Death Valley's continuing geological evolution. The giant boulders plastered high on the canyon walls illustrate the power of flash flooding in the desert. The smooth walls of Mosaic Canyon show how the dried mud from an ancient lake still affects how Death Valley is being shaped to this day. And yet, some mysteries remain unsolved, including one of the world's most intriguing geological riddles: the rocks that seem to walk by themselves, moving thousands of feet across the floor of Death Valley. Over 1.2 billion years, Death Valley has been transformed from a watery landscape to a barren desert. But even though geologists now understand the processes that have shaped this extraordinary region, there are still mysteries to be solved. And there is no part of Death Valley more mysterious than an area known as the racetrack. This parched, cracked lake basin, just 2.5 miles long and a mile wide, is the setting for one of Death Valley's most intriguing geological puzzles: its sliding stones.
I love this place because it's odd. I could come here 100 more times, and every time there'll be something different, something I didn't see.
Stretching behind these rocks are long, grooved trails in the earth. It is clear that they are tracks left behind as the rocks move across the valley floor. The puzzle is to work out how the rocks can slide uphill against this slightly tilted surface. These are no mere pebbles. Some of these rocks are over 700 pounds. And some of the trails are nearly 3,000 feet long. The phenomenon was first recorded here by scientists some 100 years ago. And yet, in this remote location, no one has ever seen the rocks moving. Messina has been tracking the movement of each individual rock on the racetrack since 1996. Her GPS readings are accurate to within a single inch.
Geology is really nothing more than detective work. And rather than looking for evidence of things that took place a long time ago, what I really like about working on the racetrack is you're looking at things that are happening right now. It's an ongoing process.
Her first clue is the surface on which the rocks slide.
If I try to move my hand over it, I could probably file my nails right now. However, after it rains, there's so much clay in the lake bed sediments that it gets slick. It's almost like Teflon. You wouldn't need very much force to set even a very large rock into motion, just because the friction on the surface is almost nil.
But water alone isn't enough to make these rocks move. Messina has identified a second factor at work.
You can have rain, but if you don't have wind a couple of days later, I don't think these rocks are going anywhere.
The racetrack is a natural wind tunnel. The wind funnels into the valley from the south. Close to the ground, the winds can exceed hurricane strength, reaching speeds of over 90 miles per hour, enough to push the rocks into action.
If you have wind and there is no friction, all you'd need to do is hit a rock with your finger like that, and it would go into motion.
When all these elements are in place, the rocks can begin their mysterious journey.
Since no one has ever seen the rocks in motion, we can only guess how fast they go. But based on some of the evidence that I've seen, these rocks aren't inching along by any means. And the best estimate we have is about 3 to 4 miles an hour. So a nice brisk walk.
But until this phenomenon is witnessed, the mystery of Death Valley's sliding rocks will remain.
I hope that this mystery isn't solved. It's what keeps me interested, and I think it's what keeps a lot of people interested.
Geologists studying Death Valley have figured out its extraordinary geological evolution. Stromatolite fossils show that this area was once covered by seas. Turtleback rocks prove that the land was stretched apart by tectonic forces, dropping the valley floor down to the lowest point in America. Pebbles at Beatty Junction prove that Death Valley was once covered with a freshwater lake. And the smooth, polished walls of Mosaic Canyon show that water is still at the heart of Death Valley's modern evolution. Death Valley remains one of the most extreme geological wonders on Earth. And it's still evolving. Its valley floor is being constantly pushed apart by forces deep within the Earth. This means that the crust here will continue to stretch and thin. One day, tens of millions of years into the future, Death Valley could be separated by the sea from the rest of the U.S. Today, Death Valley continues to sink at a steady rate of 1/10 of an inch a year, while its surface continues to be sculpted by water, living proof that the Earth is never at rest.